Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to use algebraic substitutions to simplify down integrals and evaluate them. So what we're looking at here is the integral 2 pi to 3 pi of 3 cosine squared x sine x dx. And again, this is a reasonably kind of complex thing to try to find an antiderivative for. So what we're going to do is we're going to simplify it down using an algebraic transformation here. What I'm going to do here is I'm going to make the substitution here, and I'm going to let u equal cosine x. Now, if we do that, this cosine x squared will become a u squared, but we've got to also transform the dx and the limits. So if du is cosine x, if u is cosine x, then du is going to be minus sine x dx. That's because du dx would be minus sine x. We also have to do the limits. If x is equal to 2 pi, that's our bottom limit here, then u is equal to 1 because the cosine of 2 pi is 1. And if x is equal to 3 pi, that's our top limit, then u is going to equal the cosine of 3 pi, which is minus 1. So what we can do now is we can completely rewrite our integral. I'm going to go ahead and take this 3 and bring it out front. Our new limits instead of 2 pi to 3 pi are 1 to minus 1. Cosine squared becomes u squared. Okay, sine x dx is basically our du, but you'll notice our du is minus sine x dx. Fairly easy fix. I'm just going to put a minus sign here and a minus sign out in front. This is now identically equal to du, so that minus sign, this one, needs to be carried along. This is now exactly equal to du. Also, what you can do is you can just solve this for dx and sub in there, and the minus sign will take care of itself. All right. Now, this minus sign we can just absorb into the limits. This would be integral minus 1 to 1 u squared du. Right. Again, when you absorb this into the limits, you just rearrange them. And antiderivative of u squared is u to the third over 3. And again, that's evaluated minus 1 to 1. So this is going to equal, now this is kind of nice. Those are going to reduce. So we put in our top limit, 1 cubed, minus, we'll put in our bottom limit, which is minus 1 cubed. That gives us 1 plus 1, which is 2. So I hope that this helps demonstrate how to do a substitution. My advice is this: don't do substitutions halfway. When you make an algebraic substitution like this, let u equal cosine theta, transform everything. Get your dx and your new limits and completely rewrite the integral, limits included. Then just work the new integral. Hope this example helps. Have a great day.